All right, so we got the recording started. So anyways, again, welcome. My name is Ben French. I'm instructor at the college. I've been at American River College full time now since 2005. So that's, over 15 years now. I, I've been at the college now longer than I served as a tech every day, which is crazy to me. I spent about 10 years in the field. I started teaching auto mechanics in the fall of 2000. In fact, I just got like my 20-year thanks for your service little plaque the other day in the mail from Sierra College. That's where I first started teaching years and years ago. And so I've been teaching automotive technology for a long time. And one of the classes I used to teach quite often was electrical. It was kind of one of my strongest areas. And then in recent years, I taught it for many years, and you get a little burned out on teaching the same thing over and over. At least I did. I was always looking for new challenges, and so I wrote and then taught like our hybrid program and some of our electric vehicle stuff. But my passion really is in engines and performance and motorsports, like some of the junk that you see behind me here. And so in recent years, in the last 5 years, 6 years or so, I've kind of transitioned over to that. So it's kind of fun in a way for me to go back to doing electrical and some diagnostics, because that's what I did a lot of in the automotive industry, and I really enjoyed it. I really enjoyed that challenge of figuring out what was wrong with the car. Now, sometimes that would drive you completely nuts trying to figure out what's wrong. I mean, there were several nights where I couldn't sleep, or I'd wake up at 3 a.m. and go, oh, I didn't try doing this, or I need to test that, or oh, I forgot my ratchet in that car. Anyways, uh, it definitely can be a challenge doing diagnostics. It can also be really rewarding. And what I found is that some students, some technicians, guys and gals, some folks like it, that challenge, and some folks don't. And that's something that each one of you guys will have to figure out on your own, is if that's something you like. One of my best friends, who now owns a shop in Roseville, he was one of those guys that he's like, yeah, I don't like diagnostics. Just give me the parts. I'll change them. I'll do that motor job or a transmission replacement or brakes. I don't want to do diagnostic work, right? Where I was kind of more the opposite. The nuts and bolts things were okay, but I really liked figuring out what was wrong with the car. And over recent years, over the course of my career, I guess I should say, is that kind of changed, in that I really developed a deep satisfaction of doing a kind of a labor intensive job and doing it right. Whether it was rebuilding a carburetor or an engine or something. So anyways, so that's a little bit about me. Let me talk to you about our class here. So 181, I will move this stuff around. Yeah, I always end up with so much stuff in my screen. It's a little bit cumbersome. Let me click this button, and it should make my Canvas page look a little bit more like you guys will view it on your end. Okay. Now, I've tried to set up all my classes on Canvas so that everything you need, it always can be jumped into from the modules link on the side of the page. So that modules link right there. I'm going to click that thing, and we'll jump in the modules. And so with this, our first module then is the syllabus. And in normal school, right, you have a printed syllabus. I talk about it the first class. I give it to everybody, and it's done. This is set up a little differently. The idea is that you do just what it says. If I get my annotation tools up here, read through each one. In fact, it's set up so that as you read through one, you hit the next button, you go through that one, you go through that one, you go through that one, and you'll get all the way through them, and then you guys will end up getting some points for that, as something that shows that I know that you read through the syllabus. Let me clear out these drawings, and let's get to some important stuff in here. So meters, I got my contact numbers. The best way to get a hold of me is probably email, and I do a pretty good job of checking it all the time. So I should get back with you within 24 hours, maybe 48. And every once in a while, if it's like a race weekend or something, I might be a little bit lagging on you. But normally I will get right back with you guys, okay? So email me, and if you haven't heard back, email me again. Don't be afraid, especially if it's something real urgent or something to kind of blow up that email, and I will do my best to get with you. I will also let you know when my race weekends are, and we will move due dates or whatever we got to do to make it work. So you just kind of read through this thing, go through each section. I do have all the learning outcomes and stuff, like these are the things you should know how to do at the end of this class. I'm kind of skipping forward to get to the grades, okay? Because I know how you guys are. You're like, well, how are you going to figure out my grades? Okay. This class is going to be, a pretty easy class, right? It's only one unit. However, to be honest with you, I feel like I'm giving you about 3 units worth of information. Like I did a lot of prep on this sucker, and there's a ton more information than 1 unit. Like 1 unit's like 8 hours of lecture. I mean, this is more than that. So Chris Moore, one of our other instructors, is working on kind of the 2.0 version of this class. That's probably going to be 2 units or so. I have no problems with you guys completing this class to later on filling out a waiver or something to allow you to get credit for the more intensive course, because you're going to have access to all kinds of information. Like I said, I have about 3 units worth of information for you here. Now, one of the things I didn't mention is that not only am I one of the instructors at American River College, I'm also the automotive department chair. So when it comes to like doing petitions for credit, or if you have a challenge exam or something like that, I can help you with those things. So all that stuff has to pass through my desk at some point or another. So I'm happy to help you with some of those issues. Okay. So on your grades, we have it set up here where we have a total of 250 points. But if you actually count through here, I have 100 points extra right off the bat. And so why I said this is an easy class to do well in is that it's really easy to get extra credit points for activities that you do. And so that means you don't necessarily have to do everything on this list. You can kind of mix and match your points as you see fit, right? So last semester I had some students that they missed some of the lab quiz sheets or something. I had some students where they chose, because the textbook, it's recommended. The textbook's recommended. It's not required, because I know how it is. It's tough times right now. I'm sure a lot of you guys are on a budget. And so although I think this is a good book program and you'll get stuff out of it, I made it where, well, yeah, it's on here, but you could do your Snap-on certification and substitute those points, okay? And I'll go more into the textbook here in a little bit. But it's a pretty easy class for you to mix and match your points, learn a bunch of stuff, and get a good grade in, okay? So that's the grading scale. I'll keep cruising through this, and it's got all kinds of resources and stuff for you, information-wise. And then once you're done with that, that brings us through that syllabus part of our course modules, which is essentially our very first module, okay? Now we started off tonight, I was playing our automotive technology video here, and I got the link there just for those of you who haven't seen the shop and would like to see it. And then we have some, kind of a little bit more boring stuff to get through at first, but it is important in that we have our syllabus and our automotive waiver. Now the syllabus is a little weird. To get to the section, the module 2, if you will, to get to this, I know you already had to click all the way through the syllabus, next, and read through it. So you automatically get credit for this by getting to this point. Okay, so I've had some folks ask me, well, how do I get credit for the syllabus? It's automatic. I know once you get to here, you've actually progressed through the syllabus, and I'm going to assume at that point you've read it. So if I go back to modules, what about stuff like the waiver? Well, I just added a little file here with some resources that shows you how to do screen captures, how to do different things for submitting things. You know, in normal school, right? You're able. I give you a worksheet or something. You fill it out. You give it back to me. It's no big deal. This becomes a little bit more cumbersome because you have to download stuff and fill it out and resubmit it. And we can get it done. And I find that most of you guys are getting better at doing it. One of the things I would recommend, if it's a PDF, and Canvas by and large prefers PDF files in it because they don't take up a lot of memory. If it's a PDF, make sure you save it to your desktop before you fill it out. So you click it, you download and save it to your desktop, then open it up, fill it out, save it again, make sure all that information's saved on there, and then you can send it to me and submit it. There is also a Canvas app for your phone, which I don't think is super helpful for like things like the waivers, but later on in the class, I am going to ask you to take a meter and do some just basic tests on a car and video those. Well, if you use the cell phone app, it makes submitting videos really, really easy. So that would be something that I would recommend. So let me go back to modules here. And I'll cruise down where we were. So there's a waiver for you to fill out just like we would normally for every auto class. There's some links here on the SP2 safety test from informational links. I put together a video. This video is a little bit old. I did it last summer, and but it's still relatively good. And if I click next, here is the actual link with the invitation to the online safety test. So you can jump in there if you've used it before, or if not, you can make your login, and you basically take a screenshot of your certificate and submit that. So the way we do a lot of our assignments these days on Canvas, distance learning, right, online learning, is, saving images or screenshots and submitting those. There is some tests for you to take that are built into the system. I've tried to make it as painless as I can, working within the confines of the system. Okay. Now, speaking about assignments and what's coming up, notice that I can click the assignments tab, but again, everything's under the modules tab. Also, if you want to know what assignments are coming up when, if you click your little calendar icon, it'll show you what assignments are due and when they're due and what's going on, right? So we got a class discussion, to know you, coming up here. And what's this one? The class waiver. So your first two things to do are that waiver and that discussion. Now, speaking about the calendar and this class, let me get back to our main dashboard for it. Okay, leave student view. Let me get back to 181 there. Speaking about this class was built, it was rebuilt. Initially, this class was just focused on getting you guys certified on the Snap-on 596 multimeter. That's why it was 1 unit. It's just Snap-on meters. And when we were looking for, well, what can we realistically, run distance learning? I said, well, I can do a multimeter class, but the only one I have through curriculum is really kind of focused on Snap-on stuff. And so what we decided to do was make this class work where it would work for any meter, whether it's the Snap-on 596. I have a Fluke meter here. I have a cheap like Harbor Freight style meter that I think I got that one off Amazon. Here's one from the auto parts store that was like 30 bucks. The idea is that, hey, let's get you really good just doing the basic stuff of your meter. I can still show you the information on the Snap-on so you can kind of compare its features. And, so you don't need some super expensive, crazy multimeter to do this class. But you are going to want to have some type of meter in the class. Now, my tool room guys, my lab techs at the college have been supposed to be getting me some, inexpensive multimeters that we can check out of the college. Like we can drop them off at the ranch house, like police services, and you guys can pick them up. What I found that last semester is that most everybody just, either had a meter or they purchased an inexpensive meter. And there's nothing necessarily wrong with having the, $10 or less meter. It does become a good backup, right? Like I wouldn't want to use this sucker on a hybrid or anything, but for what we're going to do in this class, this will be fine. This will meet all the basics requirements. And it's a good little backup meter to have in your glove box or something. So if something goes wrong in your car, you have that there. That's the meter that I throw in my toolbox that I take to the track with me, just so you have something, in case of emergencies. So we're setting it up where we can check out meters to you guys if you guys need multimeters. But one of your activities is you'll get whatever meter you decide to use for the class. You kind of go over the features and tell me what you like about it or what you don't like about it. And it could be that what you like about it is that, hey, it was really cheap, and that's fine too. And what you don't like about it is it's not Cat 3 certified or something. So this class kind of morphed to be more than just how to use a Snap-on meter, to be how to use any multimeter, and then how to, do electrical diagnostics. So with that, we're going to do a review of some basic electrical, which for some of you guys will be a review. Some of you guys that might be new, that's fine too. So we're going to do some basic electrical review. We're going to look at some wiring diagrams, and we're going to go through some diagnostic case studies in here. In fact, I'll go back to the modules tab. It'll look a little different because I'm in teacher mode right now. But if I scroll through here, I have how to use your meter and some basics and stuff. But then we get into charging and starting system diagnostics. And we get into some electrical case studies where we have no starts in certain things. Nothing super complicated, but we go over some pretty good stuff that shows you different ways that you could use your meter that you might not have thought of. And so I think it will come out, because I know there's some of you that I've seen your names on the list, and I see you in our Zoom here. And I know you've had the basic electrical class. So in that case, this class will serve as a very nice review for you. And there's others of you who, maybe have not had the basic electrical class. And then this class will then serve as a great kind of introduction. Okay. And to be honest with you, out of all the classes that I have taught online, this one seemed to work the best in this online format. Okay, so we'll go through it. Now you notice I have it kind of built around an 8-week schedule, right? Originally, when I planned out this semester and put in the syllabus, the schedule, this class AT181 was supposed to be 8 weeks one, And then I was going to follow that guy up with AT188, which I was in the process of building, which was our scan tool side, was going to be 8 weeks too. Much to my surprise, when I looked at these, I finally realized my brain just kept filling in the blanks automatically, and I kept missing that they weren't scheduled that way. They're both scheduled for full semester. So the scheduling of stuff is a little mixed up. What I've done here for this one, because we ran this last semester and all I needed to do was kind of add some things and tweak a few items. This class really is ready to go. Everything's there. And so I've set up the bulk of our information is, set up to progress through in the first 8 weeks. However, I give you much more time throughout the whole semester to get stuff done, which is, I think, it could be, I think it will be great if you get busy with life and stuff. But it could bite you if you're a procrastinator and wait till the end. But I even had students who did that a little bit, and then they got behind in some things and missed some stuff, but they did extra credit, like their Snap-on certification, and made up those points. So again, it's a 1-unit class. It's not supposed to be a killer. I do have information-wise, like I said, about 3 units of information. So if you're here and you want to learn a lot about electrical, you will be able to do that. You will have the information, you'll have the resources to do just that. Okay, so that's a little bit about the class and a little bit about me and my background. Like I think I shared with you before, I did a lot of diagnostics. And honestly, when I entered the car industry, I didn't need to work in it very long before I realized that I didn't like doing a bunch of brakes and tires and stuff like that. That's hard work. Like, how many of you guys out there have work in the industry or have been that brakes guy or that tire guy? Anybody out there? Well, if you do it, it's not easy work. Like, my hat's off to you for doing that work. So I realized that, hey, that's not what I wanted to do necessarily. And so I was able to use my knowledge of electrical and air conditioning to kind of transfer away from doing more of the undercar work to doing a little bit more of the diagnostic work. What I found is you start doing AC work, and a good 60, 75% of the time, an air conditioning system on a car doesn't work because the refrigerant has leaked out, right? But there's a good 20, 30% of the time where it's got refrigerant and there's some type of weird electrical problem, whether it's a defective pressure switch or a compressor clutch that's not working. And so with that, I found that, it allowed me to test my electrical skills, and it enabled me to transfer over and work on the electrical side of the industry. And then once you kind of prove yourself that you can do electrical diagnostics, usually you will not have a shortage of electrical diagnostics, because like I said, there's enough people in the industry that don't like doing that. And so they'll be like, hey, you do this. It's unlocked. All right. So with that, what I want to get started in tonight then, and we won't necessarily get all the way through it, is a couple of things. Mostly some basic electrical stuff. I want to at least start our first presentation. And so we've gone through the syllabus. We talked a little bit about the program. I gave you some of my background. I showed you a little bit of the waivers and different things and the safety test. There is videos on there that can help you do that. So I'm hoping I don't have to walk you through that type of stuff. You do have a link here to Schottky. So if, at some point you will need to look up some wiring diagrams. One of the things I like about Schottky is that it redraws all the wiring diagrams in color. I got the passcodes and stuff here for you. This might change throughout the semester, but I'll let you know if it changes. So what we're going to go into is this first presentation here, this basic electricity presentation. And to do that, what I'm going to do is get somebody admitted into our class right there. So what I'm going to do with that basic electricity presentation is I'm going to get him opened up, and I'll change my screen share so you guys can see what we're looking at here, hopefully. There we go. And now I'll put this on presentation mode, and I'll change the screen share again so you guys now can see hopefully a pretty good looking screen of automotive electricity. Okay. Now don't give me too hard of a time. Some of my graphics here are a little dated, and I will say that, you know, one of the beautiful things about learning electrical is that electricity has functioned in the same way, right? Like it behaves by the same physical properties, right? The science works the same way as it's always worked. So it's one of my favorite presentations in that I haven't had to update it like a million times because it's always changing, right? When you're doing when I was doing the hybrid class, like every single semester, it'd be like, oh, well, now there's these new models and this works differently. And this electricity is electricity is electricity, right? Once you get the basics down, you can apply what we're going to learn here on cars to, you know, working on boats or houses or doing anything electrically related. Okay. So with that, let's jump into this thing. So over the course of the next several weeks, these are the things that we're going to cover. We'll get to a few of these tonight, some electrical theory and some Ohm's law, and we'll probably finish tonight right as we get to this circuit construction area, okay? Like I said, towards the end of the class, we're going to be going into some starting diagnostics and case studies. We'll be looking at wiring diagrams. In fact, we'll look at that even a little bit maybe tonight. So with that, I have this slide just to share with you that, you know, I'm a car guy, and I don't have prejudices on any brands. Like I kind of like them all. I can appreciate every car manufacturer will have some things it does really well, and maybe some other things that could be improved. You know, after a while, you kind of learn the idiosyncrasies of that brand, and you make it work, right? All of these brands, right, will have electrical and electronic systems in them, right? So if you learn how electricity works and how it's going to function and how to use your meter, you will be able to, you know, do electrical diagnostics on all of them. The biggest thing you'll find is that some will set up their wiring diagrams a little bit different. They'll draw them differently, and then, you know, their circuit structure might be slightly different. But, you know, it comes down to that there's only so many different ways to do stuff. So now with all this stuff, it doesn't matter what brand of car you have, everything starts off with the atoms, right? Atoms are the building blocks of matter, right? You, me, our computers, our cars, my desktop here, we're all built out of atoms. And I like to start at the very basics because it gives us some insight onto where, you know, how things behave, why they behave the way they do, okay? So if you remember back to like high school science class, in an atom in the center, this red dot in the center, that's your nucleus, and you have protons in it and neutrons. The neutrons don't have a charge, but the protons, those guys have a positive charge, right? And orbiting around this sucker, we have electrons, and they have a negative charge. Now, what keeps everything connected? Well, there's magnetic fields, right? Opposites attract, and that keeps the electrons, you know, orbiting around the nucleus that has the protons, right? So it's all about magnetism and these positive and negative charges, okay? Now, I have down here, when the number of protons and electrons are equal, the atom is balanced. That's how everything wants to be, right? Like everything wants to be balanced. Just like us, like I find that most people like myself, we're kind of non-confrontational. We would just like to chill out, right? That's how the atoms want to be. They want to be balanced out. All right, moving right along then. There's something else to know about these atoms. And that is that there's rings that go around and they're not all on the same plane. So if I were to draw this thing a little differently, here's my nucleus there in the center, and I would have one ring and another ring and another ring. And so they would spread out further and further and further apart. That outermost ring is the valence electron ring. And for us, thinking about electricity, that's where all the action happens. Why? Because its electron is the furthest away from the nucleus with its protons, okay? In fact, how many electrons I have in this valence electron ring is also a really, really big deal. So if I start stacking more electrons in there, it changes what property this thing is. It changes what it is on the old periodic table. So if it's a conductor, what you would find if you got out your electron microscope and zoomed in on this thing, it would have less than 4 electrons in that outermost ring if it was a good conductor. In fact, really good conductors like copper, you would have only 1 electron in there. Okay, well, with that being said, if you had a material that had more than 4 electrons, let's say you had a material that had 8 on there, well, that would be a really good insulator. Okay, so other materials like plastics, rubber, glass, they have a whole lot of electrons on there. Now, why is that? Well, think of those electrons. Those are kind of like wingmen or your buddies in that. What we're trying to do with electricity is we're trying to mess around with these electrons and move them from one atom to another atom, okay? Well, if these electrons have friends, right, that are helping hold those guys accountable, hold them in place, it's really hard to get one electron to break away. So it's going to be a insulator. However, if there's nobody else, it's just one guy by his lonesome, one electron out there, it's easy to grab him and move him from one atom to another. So the valence electron ring and how many electrons are in that ring is a huge deal because it determines how is this material going to behave, okay? In fact, if I have exactly 4 electrons, now I'm a semiconductor, meaning that I can conduct electricity in one moment. The next moment, I could decide to stop that conduction of electricity. Basically, I can turn on and I can turn off really quickly. Again, these electrons, why they're so important, they're the loosest held because they're the furthest away from the nucleus. Okay, so we'll clear out those drawings and keep going. So again, things with a low amount of electrons in that outermost ring are going to be good conductors. Good conductors are things like copper, gold, right? Aluminum's a great conductor. Steel, think of like your steel frame, that type of thing. Other items that would be the opposite then would be like insulators, right? They have a lot of electrons in their outermost ring. Rubber, wood, glass is a real good insulator. Most of your plastics obviously are good insulators. So what determines if it's a conductor or an insulator? It's all about the atomic level, man. It's all about what happens there at the very basis of stuff. What about those ones with exactly 4? That's a semiconductor, right? So that's the building blocks of electronics. That's our computer chips, right? So if we think of, you know, silicon and Silicon Valley, right, building computer chips, that's all about semiconductors. And what I like to think about is that, you know, the way this works is absolutely amazing. For instance, right now we're online. I'm talking to my computer. You guys are looking at your computers or tablets or whatever. And my voice is being converted into a digital signal, the video too, and it's transmitted through the internet, right? That digital signal is a on off signal. I'm trying to draw it out. I'm not doing a great job, but you get the idea. It's a series of ons and offs, or ones and zeros, and ones and zeros over and over and over again. Well, how do I get these ones and zeros or ons and offs? We get those by a semiconductor allowing electricity to go through in one moment and then stop the next moment. And then the electricity can go through again and then stop and then go through. So, I mean, it all comes down to what the materials are and what's going on with those electrons. I think that's pretty neat, pretty darn amazing when you think of it, right? So now we kind of know how, you know, how our materials behave. I think what is also important is to then start looking at, well, how are these atoms going to react with each other? Well, in some materials, you're going to have electrons just bouncing back and forth and moving a little bit between atom to atom, which is not a big deal. That's called random electron movement. But if I can take these atoms and I can direct them a certain direction, now I got something going on. Now I can direct that flow of electricity, and that's what it's all about, okay? So how do I do that? I need to set up some pressure to get electrons to move where I want them to move. And so I do that by creating an unbalanced deal here. So remember how I said how, you know, atoms, kind of like people, they just want to be balanced out. They just want to chill out there, right? Well, if I were to take this electron and move him from this atom, and I moved him over here, okay? Now this guy has an overall negative charge, and the other guy has an overall positive charge. What I've done is I've set up a positive and I've set up a negative ion, okay? So you probably heard this term ions. They'll talk about, oh, that's a lithium ion battery. It's, you know, we're moving ions around through the different materials, through the membrane of the battery, okay? Well, what are those ions? They're charged atoms, right? And we're playing around with the electrons on them. We don't move the protons around. It's always moving the electrons around. So I'll erase these scribbles. And so we, you know, just to summarize everything, right? The amount of electrons in the outermost ring determines what type of material it is, right? And, you know, at the core of this is it's all about magnetic fields as well. And what is their strength of their hold on the electrons? Now, if I take these positive ions and I take the negative ions and I start to like stack them up, really get them to build up here. Start stacking these things. And I'm going to put a piece of insulator in between too, so they can't just blow through that gap there. If I start stacking them up like that, I'm going to create more and more potential difference between these two. This potential difference has a couple different names. In electronics, it's commonly called electromotive force, or EMF, okay? For us, we will commonly call this voltage, right? It is our electrical pressure. How do I get it? By separating out a lot of positive atoms, positive ions, I should say, and negative ions. And in something like a battery, we stack all these guys on a positive plate and a negative plate. So a battery really is a series of plates, and these different plates have positive charges and negative charges. All right. So we'll clear out those drawings and we'll keep going. So we've just made some voltage. And again, voltage is electrical pressure. And if I don't have any pressure, nothing's going to happen, right? And that makes sense, right? Everybody knows that, hey, if your battery's dead, it's game over, right? Nothing happens. You have to have voltage. You have to have some electrical pressure to get electricity to flow at all. You got to have some pressure, okay? Well, the next part of the equation is current flow, okay? So it's no longer random movement, but now we're directing that movement through a conductor, right? Through a piece of wire, let's say. We're letting that guy, we're letting those electrons move through those wires. And why? Because there's a potential difference. There's voltage being put on that, right? So the voltage, the pressure is what causes the flow. This current flow is measured in amperes or amps. And this is not a typo. It takes a lot of amps to move a lot of electrons to basically equal 1 amp. So 6.28 billion electrons past 1 point in 1 second is 1 amp. So it's a pretty amazing amount. So if I get in my car and I go to start it and I'm cranking it over and it takes 125 amps cranking it over to turn over the engine from the starter motor, I mean, just imagine how many electrons that is. And that's why current circuits that require higher amounts of current flow are going to have to use in them, they're going to have to use thicker wires in there, right? In order to make that work. We're going to have a thicker cable in there to handle all those electrons passing through it. Now, there is another part to this equation that comes into play here, right? And that's resistance, and that there's always going to be some opposition to the flow of all these electrons moving through these wires or these components. And that's what resistance is. It's this reluctance of the atoms in that material, whether it's the component like your light bulb or the wires, it's the reluctance of that atom to give up its electrons and let them move on over to the next atom, right? We measure this property, we measure this resistance in ohms. And how we will typically show that is by the Greek omega symbol. So if you look on your meter, like this one here, up in the top, it's got the Greek omega symbol for its ohms measurement. So there's always going to be some ohms in place there. Usually what's supposed to have your ohms is the device you're trying to operate. So if you're trying to operate a light bulb or a buzzer or a cooling fan or a fuel injector, that's where the ohms is supposed to be, in that device, in that load. The wiring should have relatively low resistance and not affect the overall function of the circuit. Okay, so we'll clear those out. And okay. All right, so let me see how I'm doing for my time here. We got a few minutes left. This is kind of a weird deal, by the way, tonight. I also have my meter class, and like I said, because they both started at the first day of school, I wanted them both to run on Thursday nights. And I'm also trying to work around other teachers' schedules for like the automotive parts class or the AT100 classes. And so I wanted to keep these on Thursday nights while I have both classes essentially starting tonight. So for what we're going to do tonight is wrap up at 7, and then I'm going to shift gears and talk about our scan tool class, our 188 class. Okay. After this first week, I'll probably have my scan tool guys take a break for a few weeks so I can just really focus for like about an hour and a half or so on electrical stuff and cover a lot of material with you guys. And then we'll kind of switch over to the more time on the scan tool class later on. Okay. So a couple things on resistance rules, and that is voltage always drops as current flows through the resistance. And if you think about how this stuff works, right? Think about imagine I had like a garden hose here, and the current is the flow of water through the hose. Resistance essentially would be a kink in that hose. And we know if we've ever pinched a garden hose or driven over it with our car, right? It's going to have a lot of pressure over here. I'm not going to get much flow through the kink there. And if I put a pressure gauge on each side, I definitely would have a drop in pressure, right? Well, voltage is electrical pressure, so this makes sense. Voltage is always going to drop as current flows through resistance. Think of that resistance as that kink in the hose right there. An increase in resistance, so if the ohms go up, means that the current flow, the amps, are going to go down. And then all resistances change some of their electrical energy into heat energy. Okay. Whenever you have electricity flowing through resistance, it's going to get warm. Okay. If you ever find a fuse panel and the whole back of it's melted and it's weird, you know, wires, either we were trying to flow way too much current through those components, through that fuse panel, or it had bad connections. It had resistance there. As the current flowed through that resistance, it got hot, and that heat is then what melted things down. All right, we'll erase those scribbles and keep going forward. So like I've already been doing a little bit for you guys, there's a water relationship, right? Where voltage, hey, that's just like your water pressure, right? And if I don't have any water pressure, I'm not going to get any water flowing down the pipes. So I got to have voltage. I got to have pressure. Current is my water flow. Now, here's what's very interesting that I want you guys to understand. It's the current flow that does the work. Okay? It's not the voltage. The voltage creates the pressure, but it's the current flow that does the work, right? The easiest way I could explain it is like, you know, it's not the water pressure at the water tower, but it's actual water flowing out of your hose and hitting your car that washes the dirt off your car, right? The current does the work. If you were to grab onto some high voltage cables and electrocute yourself, it's the current flowing through your body that would stop your heart and kill you, okay? Current does the work. Resistance, like we said, is like a kink in the hose, and that's going to create a pressure change. And it's also going to affect how much current we can flow through those lines, right? These three dudes work together in a relationship we call Ohm's law. And, you know, I find that a lot of times when you start talking Ohm's law, I've had a lot of students get pretty nervous about it and all kinds of stuff. What I will say is that, you know, with Ohm's law, it's always there, whether you want to, you know, realize it's there or not. Okay. And so for me, I like to just know, hey, it's there and not get too caught up on it. But I do think it's important to understand, right? Because when we think about diagnostics, electrical diagnostics with our meter, at some point, we're going to be measuring voltage, current, or resistance with this thing. We're going to measure it someplace on the car, and we're going to have to ask ourselves, well, am I measuring what I expected to measure at this particular spot? And if I'm not, I have to ask myself why, because maybe that's what my problem is, right? Well, how do you know what to expect? By understanding electricity and how it works, and that means understanding Ohm's law, okay? So I got two definitions for you here. The top definition is like the English teacher definition, okay? And the bottom definition, I would say, is more the math teacher definition. And this is one where I kind of prefer the math teacher definition here. Now, we have some unique terms because I set this up after like electronics classes where they would talk about I for current flow. That comes off of an old term called intensity. Okay, but essentially this I, think of that as an A for amps. The amps or current flow equal the voltage, EMF, voltage, right? I'll change this to a V, divided by the resistance. And basic algebra being what it is, I can cover up whatever I want. So for instance, if I wanted to know what the resistance was, I could take the voltage and divide that by the current flow. So I can manipulate this formula all around. So if I go to the English teacher definition, that definition says, hey, the current flow through a circuit, it's directly proportional to the voltage applied to the circuit, right? Like if I apply more voltage to it, it's going to flow more current, right? That totally makes sense. But it's inversely proportional to the resistance, meaning that if I have more resistance in the circuit, then the current flow is going to go down. So both these definitions make sense when you think them through. It's just two different ways to look at it, to explain it. And of course, with that Ohm's law pie chart, you can always figure what you're looking for by covering that up with your fingers. So you give it the finger and you can calculate what you're looking for there. Now, we'll finish up on this one right here. This is my real world Ohm's law issue. And I put this slide together a number of years ago because well, I had two experiences. I had a student who was a really skilled mechanic, many years in the industry, and when we started talking Ohm's law, man, he just shut down. He's like, "Oh, I've been in the industry 20 years. I never use Ohm's law." Okay, and then in my early days at American River College, when I first started, and this is before I was even full time, so this is like maybe 2000, 2004, 2003, something like that. I started and they said, oh, well, we're a Toyota school. You got to go to the Toyota factory classes. So I go there, and the first day of Toyota factory class, the teacher says, okay, well, this is our electrical class. We're not going to talk about Ohm's law. And I thought, well, that's kind of weird. Why would you not do that? Well, because they had the same experience where you start talking to Ohm's law and people start getting freaked out. Okay. What I want you guys to realize is that you could be doing Ohm's law stuff all the time without even thinking about it. Right. How many of you guys have looked at a car and saw that the battery cables looked like this one I have on the screen, and you cleaned off those cables? How many of you guys have done that? Why don't you, if you guys are Zoom savvy, there's a way that you can wave your hand, give me a thumbs up. Yep. I see Ramses has, a few of you guys have, right? You've cleaned the battery. You're doing Ohm's law. Okay, and you might not realize it, but you are. For example, okay, we know that this battery, if it's fully charged, you guys help me out. How many volts is this battery should it have if it's fully charged?
12.5.
Yeah, actually it's 12.6, but that's really good. Okay, 12.6 is a fully 100% charged battery. Okay. 12.5 would be like, I don't know, 95% state of charge, right? It is kind of a misnomer because we'll say, oh, that's a 12-volt battery, right? But really it's 12.6 volts. It should make 2.1 volts per cell, and it's got 6 cells. So I got a battery, it's 12.6 volts. Now, how many amps does it take to crank over your engine to start it up? Well, that depends. It depends on the size of the engine, how much friction the engine has, how cold is it outside, what is the thickness of the engine oil, right? But generally speaking, I'm going to say most cars on the low end would take about 90 amps to crank over. And on the high end, they take like 180 amps. 180 amps would be like, you got a big block V8 or something in there, okay? So let's say I have your, run-of-the-mill average, V6 or something, and it takes 130 amps to crank over the engine. Okay. We also know that at best, my battery is going to have 12.6 volts, right? So what does Ohm's law say to do? If you wanted to figure out, well, how much resistance could I have and have this thing work? Well, I divide 12.6 by 130. And so what I'm going to do what I'm going to do here real quick, if I can. A lot of things on my screen. Oops, I need to go back. What I'm going to do is, well, you know what? I will just cheat. I will use my cell phone calculator so I don't have to switch screens 100 times. I normally like to bring up the calculator, but anyways, so I'm going to divide, I'm going to take that 12.6 and I'm going to divide him by 130. All right. And I get point, and I'll type it on here, 0.096. I'll round that up to 0.097. So we'll get our little text tool back going. So 0.097 ohms. So what that means is, heck, that's not even an ohm. It's not even like 0.9 ohms is close to 1 ohm. This is 0.09 ohms. I mean, it's not even a tenth of an ohm. It's next to nothing. So I can't have very much resistance at all at this battery connection and be able to pull the current through it that I need to pull to crank over the engine, right? And that's why if I came in here and I cleaned up these battery cables with some baking soda and water and a wire brush and got that all nice and clean, oftentimes that would take a car that maybe was a no start or an intermittent no start or maybe a slow crank and make that car so that now it could start up and run, right? Because I have, what I just did there is I lowered the resistance by cleaning the battery terminals. And what Ohm's law tells me is if the resistance goes down, the current flow is going to go up, right? If the voltage stays the same, which, you know, it's one of those things where it's pretty easy for most people to figure out when you got a dead battery, right? So, you know, you can figure out I got a dead battery. That's pretty straightforward. So if the voltage stays the same at 12.6 volts or 12 volts, we'll say, if the current flow, if the resistance goes down, the current flow is going to go up. Likewise, if the resistance goes up, that means the current flow is going to go down. And that's the relationship that's really important to understand with Ohm's law. The most common problem we have on cars is either bad components or bad connections, C and C. And with bad connections, those bad connections will cause the resistance to go up, the current flow goes down, and now the circuit doesn't work correctly, right? So remember, it's the current that does the work in the circuit. All right, that is a good place for us to stop with our electrical lecture this evening. Remember that, if I can get this thing to exit out, and I will change my screen share to the internet. Okay, there we go. Remember that this presentation that I used is right here, basic electricity. It's a pretty big presentation. It takes a little bit for it to load, but it is in that kind of first beginning week's materials. So it's not like I'm not going to be ever showing you stuff in our class Zoom time that you guys don't already have access to in Canvas, okay? You will have access to all my materials. You can download those. You can do what you want with them, okay? So hopefully that kind of got us started, answered some of your questions. What I do need to do is shift gears because now I have my, my scanner class should be starting here. So I'm going to do one last thing. I'm going to stop my recording. Let's see here. Stop.